find the diameter of the sun if the angular diameter of the sun is 0.0093 radian and the sun earth distance is 1.496 into 10 to the power 11 meter. So what is given? The angle is given 0.0093 radian and D, the diameter is also given 1.496 into 10 to the power 11 meter. Therefore, the diameter of the sun small d is equal to the angular diameter into alpha. Therefore, angular diameter is equal to 1.496 into 10 to the power 11 into alpha means 0.0093. When you solve, you will get 1.39 into 10 to the power 9 meter. Note that the diameter of the sun is about 109 times the diameter of the earth. This is very important thing. Now we are going to see another numerical. A planet is at a distance of 8.247 into 10 to the power 8 kilometer from earth. Its angular diameter is 35.72 inch of an arc. Calculate the diameter of the planet. We know the formula. Diameter of the planet is given by small d is equal to capital D into alpha. Capital D is 8.247 into 10 to the power 8 kilometer, and here alpha, the angle is given as 35.72 inch. We need to convert this inch into radian, and the formula is 35.72 inch divided by 3600 into pi divided by 180 means it will get converted into radian. Remember this formula, since they gave angle in terms of inch, we need to convert it into radian first. Hence, small d is equal to capital D into alpha. So, capital D is 8.247 into 10 to the power 8 and alpha is 35.72 divided by 3600 into pi upon 180. So, when you solve, you will get 1.426 into 10 to the power 5 kilometer. When the planet Jupiter is at a distance of 8 to 4.7 million kilometers from the Earth, its angular diameter is measured to be 35.72 seconds of an arc. Calculate the diameter of the Jupiter. So here they gave angle alpha is equal to 35.72 seconds of the arc. So we need to convert it into radian. Therefore 35.72 divided by 60 into 60 into pi upon 180 means it will convert it into radian. Now capital D they already gave 824.7 million kilometers, means when you convert million in million can be written as 10 to the power 6 kilometer. Now we know the formula small d is equal to capital D into alpha. Just substitute the value of capital D and alpha in the formula. You will get 1142817.8 kilometer. Find the distance of the moon from the earth if the parallax angle as measured from the two places at a distance of 6.4 into 10 to the power 6 meters on earth is 57 minutes of an arc. So we know the formula capital D is equal to small b upon theta. B is 6.4 into 10 to the power 6 meter and theta is 57 minutes. We need to convert it into radians. So 57 into 60, then it will be converted into inch. Then we will convert it into radian. The formula is divided by 3600 into pi upon 180 and substitute the value in the formula. When you substitute, you will get 3.858 into 10 to the power 8 meters. One of the satellite of planet Jupiter has time period 1.769 days and orbit in a circular orbit of radius 4.22 into 10 to the power 8 meter. Calculate the mass of the Jupiter. The mass of the Jupiter is given by capital M is equal to 4 pi square r cube upon g into t square. They already gave r is equal to 4.22 into 10 to the power 8 meters. G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Capital T periodic time is 1.769 into these days we need to convert it into seconds. So 86400 seconds. So when you substitute the value, you will get 1.92 into 10 to the power 27 kg. One of the satellites of Jupiter has an orbital period of 1.769 days and the radius of the orbit is 4.22 into 10 to the power 8 meter. Show that the mass of the Jupiter is about 1000 that of the Sun. Take 1 year is equal to 365.25 mean solar days. Here the orbital period of the satellite of Jupiter is given T1 is equal to 1.69 days. We need to convert it into second. Therefore, multiply by 24 into 60 into 60. So when you solve, you will get some answer. Now the radius of the orbit of the satellite of the Jupiter R1 is equal to 4.22 into 10 to the power 8 meter. Therefore, the mass of the Jupiter is given by, we know the formula capital M, we will denote by suffix j since we are calculating it for the Jupiter. So mj is equal to 4 pi square r1 the whole cube upon g into t1 the whole square. So when you substitute, you will get 4 pi square into 4.22 into 10 to the power 8 the whole cube divided by g into 1.769 into 24 into 3600 the whole square, and it will come in kg. We know that the orbital period of the earth around the sun is T2 is equal to 1 year. Our 1 year is equal to 365.25 into, it is the days. So we will multiply it by 24 into 60 into 60. The radius of the orbit of the earth R2 is equal to 1 astronomical unit, that is equal to 1.496 into 10 to the power 11 meter. Therefore, mass of the sun is given by ms is equal to 4 pi square r2 the whole cube upon g into t to the whole square. Just substitute all these values and you will get equation 4 pi square into 1.496 into 10 to the power 11 the whole cube divided by g into 365.25 into 24 into 3600 the whole square. Don't solve this because we are going to find the ratio. So ms upon mj is equal to 4 pi square into 1.496 into 10 to the power 11 the whole cube divided by g into 365.25 into 24 into 3600 the whole square into g into 1.769 into 24 into 3600 the whole square divided by 4 pi square into 4.22 into 10 to the power 8 into the whole cube. When you solve, many things are common. G will get cancelled. 24 into 3600 will also get cancelled, and 4 pi square will also get cancelled. You will remaining with the answer 1045. Hence, the mass of the Jupiter is 1041 by 1045. That is about 1 by thousands that of the sun. Calculate the mass of earth from the following data. Radius of the earth 6 into 10 to the power 6 meter. Acceleration due to gravity 9.8 meter per second square. Gravitational constant capital G is equal to 6.67 into 10 to the power minus 11 Newton square meter square per kg square. So suppose capital M is the mass of the earth. If a mass small m is placed on the surface of the earth, then the gravitational force of attraction between mass and earth is given by, we know the formula capital F is equal to G_mm upon r square. We know that force is equal to mass into gravity. So capital M is equal to, we will cancel, we will equate the two equations, G_mm upon r square is equal to m into g, will get cancelled. Therefore capital M is equal to g r square upon g. We know the value of g, we know the value of capital R, we know the value of g. Just substitute the value, we will get 9.8 into 6 into 10 to the power 6 the whole square divided by 6.67 into 10 to the power minus 11. When you solve, you will get 5.289 into 10 to the power 24 kg. Calculate acceleration due to gravity on the surface of the moon. Given that mass of the moon is equal to 7.349 into 10 to the power 22 kg. There is a printing mistake. They wrote as 10 q2. It is 10 to the power 22 kg. Radius of the moon is equal to 1.738 into 10 to the power 6 meters. Solution. Acceleration due to gravity on the moon is given by, we know the formula, small g is equal to capital G into capital M divided by r square. Substitute the value, capital G is equal to 6.67 into 10 to the power minus 11 Newton square meter square per kg square. Capital M is equal to 7.349 into 10 to the power 22 kg, and capital R is 1.738 into 10 to the power 6 meters. So when you substitute and solve, you will get the small g is equal to 1.62 meter per second square. Estimate the surface temperature of the sun. Given the radius of the sun is equal to 7 into 10 to the power 8 meters. Sun earth distance is equal to 1.496 into 10 to the power 11 meters. Solar constant is equal to 1.388 into 10 to the power 3 watt per meter square, and Stephen constant is equal to 5.67 into 10 to the power minus 8 watt per meter square per k to the power 4. So we know the luminosity of the sun is given by Ls is equal to 4 pi square r square capital S, which is equal to 4 pi 1.496 into 10 to the power 11 the whole square into 1.388 into 10 to the power 3. When you solve, you will get 3.9 into 10 to the power 26 watt. Energy radiated per meter square of the sun's surface per second. Capital E is equal to 3.9 into 10 to the power 26 upon 4 pi r square is the energy radiated formula. Just substitute the value, you will get 6.41 into 10 to the power 7 watt per meter square. According to the Stefan's law, we know the formula E is equal to sigma times t to the power 4. So T is equal to E upon sigma to the power 1 by 4. So after substituting and solving, you will get 5800 Kelvin. The amount of heat radiation received by the earth from the sun is 1.38 into 10 to the power 3 watt per meter square. Suppose all this radiation on the earth are re-emitted by the earth. Calculate the surface temperature of the earth. Stephen's constant is equal to 5.67 into 10 to the power minus 8 watt per meter square per k to the power 4, which is given. So according to the Stephen's law, we have E is equal to sigma t to the power 4. So T is equal to E upon sigma to the power 1 by 4. After substituting the values and solving, you will get 395 Kelvin. If the radius of the sun is 6.95 into 10 to the power 8 meters and its distance from the earth is 1 astronomical unit, calculate the surface temperature of the sun given the Stephen's constant is equal to 5.735 into 10 to the power minus 8 watt per meter square per k to the power 4, and the solar constant S is equal to 1.39 into 10 to the power 3 watt per meter square. So we know the formula capital T, that is the surface temperature of the sun, is given as capital R upon small r to the power 1 by 2, capital S upon sigma to the power 1 by 4. Radius of the sun is denoted by small r is equal to 6.95 into 10 to the power 8 meters, it is given. Distance of the earth from sun, capital R is equal to 1 astronomical unit, that is 1.496 into 10 to the power 11 meters. Stephen's constant sigma is equal to 5.735 into 10 to the power minus 8 watt per meter square per k to the power 4. Solar constant S is equal to 1.39 into 10 to the power 3 watt per meter square. Just substitute in the formula, you will get 5788.3 Kelvin as the solution. The luminosity of the star is 10,000 times that of the sun and its surface temperature is 3000 Kelvin. Assuming the surface temperature of the sun to be 6000 Kelvin, compare the radius of the star with that of the sun. We need to compare, means we need to find the ratio. So let L1 and L2 be the luminosity of the sun and the star respectively, and R1 and R2 be their respective radii. Therefore, L2 is equal to 10,000 times L1, T1 is equal to 6000 Kelvin and T2 is equal to 3000 Kelvin, which is given. Substituting, L1 upon L2 is equal to 4 pi R1 square into sigma T to the power T1 to the power 4 divided by 4 pi R2 square into sigma T2 to the power 4, which is equal to R1 upon R2 the power square into T1 upon T2 to the power 4. Therefore, R2 upon R1 is equal to L2 upon L1 to the power 1 by 2 into T1 upon T2 to the power square. Since we are taking root of both sides, so our formula changed like this. Now substitute the values, 10,000 L1 upon L1 to the power 1 by 2 into 6,000 divided by 3,000 the whole square. You will be remaining with 400 as the solution, that is R2 upon R1, which will be equal to 400. Surface temperature of the sun is 6000 Kelvin. If we consider it as a perfect black body, calculate the energy radiated by the sun per second. Given the radius of the sun is equal to 6.92 into 10 to the power 8 meters and sigma is equal to 5.67 into 10 to the power minus 8 joule per meter square per second per Kelvin to the power 4. So energy radiated by the sun per second, we have the formula E is equal to A sigma T to the power 4 A is equal to 4 pi r the whole square. So just substitute the value of r, that is 6.92 into 10 to the power 8. So we will get area is equal to 4 pi into 6.92 into 10 to the power 8 the whole square. Sigma, which is given 5.67 into 10 to the power minus 8 joule per meter square per Kelvin to the power 4. T is equal to 6000 Kelvin. Substitute all this value in the equation. E is equal to A sigma T to the power 4, and when you calculate you will get 4.42 into 10 to the power 26 watt. Earth receives an amount of heat radiation 1.4 into 10 to the power 3 watt per meter square from the sun. Assume the Earth re-emit all the radiation received from the sun. Calculate the surface temperature of the Earth. Let capital T be the surface temperature of the sun. The amount of radiation received by the Earth from the sun is equal to 1.4 into 10 to the power 3 watt per meter square. Since the Earth re-emit all radiation received from the sun according to the Stefan's law, we know the formula sigma T to the power 4 is equal to 1.4 into 10 to the power 3. So just T is equal to 1.4 into 10 to the power 3 divided by 5.67 into 10 to the power minus 8. Since T is to the power 4, so we need to divide by 1 by 4. So capital T is equal to 1.4 into 10 to the power 3 upon 5.67 into 10 to the power minus 8 to the power 1 by 4. When you will solve, you will get 396.4 Kelvin. A star will appear red if the wavelength of the maximum emission is in the range of 6500 Armstrong degree to 7000 Armstrong degree. Find the temperature range of the sun. Given Wayne's constant is equal to 2.897 into 10 to the minus 3 meter Kelvin. So according to Wayne's displacement law, lambda m T is equal to B. So T is equal to B upon lambda m. Just substitute the value of B. We know it is 2.897 into 10 to the minus 3 divided by lambda m. They gave as 6500 into 10 to the minus 10. When you solve, you will get T1 is equal to 4457 Kelvin. Now T2 is equal to, similarly, just to change the temperature, because they are telling the range is from 6500 Armstrong to 7000. So change it by 7000, lambda m will replace by 7000. So T2 is equal to 2.897 into 10 to the power minus 3 divided by 7000 into 10 to the power minus 10 is equal to 4139 Kelvin. So the star will appear red in the temperature range 4139 Kelvin to 4475 Kelvin. A star has a surface temperature of 1500 Kelvin. The star will radiate its maximum energy in what part of the spectrum? Given the Wayne's constant B is equal to 3 into 10 to the power minus 3 meter Kelvin. According to Wayne's displacement law, the wavelength lambda m at which the maximum radiation occurs is related to the surface temperature. Lambda m is equal to B by capital T. We know B is equal to 3 into 10 to the power minus 3 meter Kelvin. T is equal to 1500 Kelvin. Substitute the value, you will get lambda m is equal to 2 into 10 to the power minus 6 meter. Therefore, the sun will radiate maximum energy at a wavelength of 2 into 10 to the minus 6 meter, which falls in the infrared region.